Sometimes software goes wrong. Today we're going to talk about two major software disasters, Y2K and the Boeing 737 MAX incidents. Welcome to Kopec Explains Software, the podcast where we make computing intelligible. So Rebecca, this week we're going to talk about two major software-related incidents, one of which happened about 2 decades ago, and the other of which is quite current. My dad actually used to do research into complex system theory and major software accidents, so it's an area close to my heart. I think you're going to get us started with the 737 MAX disasters.
Before we talk about the disasters that happened, we should take a step back. The 737 MAX is a passenger airplane, and it's part of the 737 series of airplanes that first came onto the scene in 1968, and it's one of the most popular, most common passenger airplanes that's still in use today.
So tell us about this new version, the 737 MAX.
The 737 MAX was made as a replacement to the 737 NG, which stood for Next Generation, and it first entered service in 2017.
But quickly, there were problems and two terrible disasters. So tell us a little bit about those disasters and what caused them.
On October 29th, 2018, the Lion Air Flight 610 crashed. Everyone on board died, tragically. And then on March 10th, 2019, Ethiopian Airlines Flight 302 also had a similar accident. In total, 346 people lost their lives.
Do we know what caused those disasters?
We do. And this is something where now I'm going to talk a little bit about how airplanes work, and I'm not an airplane expert or a flight expert, so I hope folks will just bear with me as we talk about this software. Pretty much what happened was a software error. The Maneuvering Characteristics Augmentation System, MCAS, was developed in order to correct an issue with the 737 NG angle of attack. Well, what was going on with the MCAS, or what it was supposed to do, is help to manage the pitch of the plane, which is like whether the nose of the plane is going up or down. And it wasn't doing that correctly. What was happening is it was interpreting some sensor readings wrong, MCAS was, and it would then cause the wrong pitch in the plane, which was obviously a big issue. If you're flying the plane and the nose starts going in a direction that you're not expecting it to, the pilots are going to react. So this software issue was taking control of the plane and fixing a problem that wasn't actually happening.
So let's just break this down again for the listeners. So the plane was going at a certain angle, and the sensors were reading it going at a different angle, and the software was trying to correct for that wrong angle. So it was a software issue in terms of interpreting the data in the sensors.
Mm-hmm. And the MCAS could actually change the pitch, the angle of the plane.
So the software was actually going and automatically correcting the plane's angle without the pilot intervening. Is that right?
That's correct. The reason MCAS was actually developed was this kind of hardware issue, an issue with the plane itself, the size and the weight of the plane. As the 737 has been in service, there's more things added to it, more things with the weight and distribution. So MCAS was kind of like a patch to fix that instead of, I guess, redeveloping the whole airplane itself.
That's very interesting. So there were some fundamental design issues with how the airplane had evolved over time through its many decades of service and new versions that had come out. And in this latest version, they added this software system, MCAS, to try to correct for some of those fundamental issues with how the plane had evolved over time.
Yeah.
And try to make it actually better for pilots. How come people weren't ready for this issue? How come this issue got out there? And how come pilots weren't able to navigate this issue?
Well, this is where it gets really, frustrating and tragic. Like 346 people really did not need to lose their lives. The MCAS system wasn't in the operations manual. So pilots were unaware that this could happen. They didn't know that there was a system that could interpret this sensors in a certain way. And there actually was a way to counteract this. If they had been aware that MCAS could change the pitch of the plane, there was a system that they could do to reset and take back control of the plane or fix it without crashing. But the pilots didn't know because they didn't even know MCAS was a thing.
Wow, that's shocking. So the pilots were never really properly trained on this system.
Correct. They weren't trained at all. And it's something that's like hard to wrap your head around that this could just be left out when it could have obviously had such a huge impact. And in the investigation of these crashes, they actually found some internal documents from Boeing and then from the FAA where they knew that this was an issue and actually thought that it could cause up to 15 airline crashes.
Wow. So they actually had internal emails within Boeing talking about this potential issue.
Yeah.
So it sounds like what we have a real software issue. We have a system that was making some mistakes on a software level, but then we also have some issues about how software ends up getting integrated into our society. So we're used to all the time having error-correcting software working for us. For example, if your oven starts to get too hot, a modern oven, if it's getting way too hot, will automatically turn itself off, right? So that's auto-correcting software that's there for our benefit as users. The intention here, it sounds like, was, of course, to be beneficial, to make the plane easier to use, automatically compensating for a problem that can happen in terms of the angle and the design of the plane. Yet, what was happening was because of the way that software was integrated and errors in the software itself, we were seeing true disasters happening that could have been prevented actually from the human side. Because really there's human error here as well, in the sense of people making decisions based on business deadlines, people making decisions based on not wanting to have to do retrainings or maybe issues in terms of certifications of these airliners. Can you tell us a little bit about that?
Yeah, so Boeing got into some, I think, in my opinion, some pretty deserved trouble for this. But one of the issues is that they wanted to meet their production goals for the 737 MAX. And so they were pressuring the FAA regulators to approve the plane and say it was safe. And so they weren't necessarily sharing all the information about MCAS, and they were kind of saying like, yeah, all the training, everything's fine. And they weren't even mentioning the system. Even after the first crash, they sent out an addendum to the operations manual saying like, oh, here's how to fix this thing that could happen. And they managed to do that without saying the system that was failing.
Wow, that's very interesting. It just shows you that, it's easy to go and blame software. And of course, there were real software errors in this case. But a lot of the problems that software causes are actually the result of human errors. And those human errors may be bad business decisions. They may sometimes be bad technical decisions. The original programs that have errors, of course, were caused by programmers who made mistakes. But a lot of this tragedy is actually human error coupled with software error.
Absolutely. So now it's in the manuals. Like, they've made that change. It took some pretty drastic measures. Well, it took another crash, right? The Ethiopian Airlines Flight 302 on March 10th, 2019, before all 737 MAXs were grounded. There was a whole lot of investigation. There was a software patch, a software update on March 27th, 2019. So we think, right, that this error shouldn't happen anymore. There's been some additional changes as well, one of which is I would say there are 3 additional changes. It's MCAS. We all know about it. It's in the manual. The training for pilots is different. So originally they were saying, all right, MCAS is a thing, but pilots who are learning, transitioning to the 737 MAX, you don't need to practice in a flight simulator. You can use just a computer to practice. And they've now gone back from that and said, actually, you really should practice in a flight simulator. So you know how, and I guess I would imagine, I've never been in a flight simulator, how it can interact and feel in the plane.
Yeah, and we're not aviation experts. I think what we can use this case as in our podcast is a lens to think about software errors in general that affect society. And I think the lesson from this for our podcast and for our listeners is that you can't just go and say, well, it's a software's fault. There's always a human story behind those software errors. And like I said, sometimes it's a simple human story where it's a programmer made a mistake. And that might have to do with the sensor readings, right? But then there's a much bigger human error, which is the business errors, the rushes to production, the not putting safety first that happened in coordination with those software errors. So I think behind every software error is some kind of human error, and that's what we always need to really explore.
Absolutely. And, these planes, the 737 MAXs, are actually now back up and flying again. With this training, Boeing is back to producing them and selling them. And we have to hope that it's a lesson learned. I mean, Boeing has had some changes out of this disaster. They have a new CEO who's saying that they're going to be much more transparent and committed to safety. You gotta hope so. 346 people lost their lives. You really need Boeing to have learned a lesson. They've also settled, instead of going to court, they've settled and they're going to be paying $2.5 billion. And that includes some money to the folks who lost loved ones. Obviously, that doesn't make up for losing your loved one, but I just wish someone did things different. Like you were saying, like it is a human error. There's a chain of human errors. Like this is according to one article I read, it was a few lines of code that were making this one mistake. And I'm sure MCAS is like a whole bunch of code, just knowing like many, many, many lines of code, right? So if it's a few lines of codes that were making this error, and it's not necessarily just this like one programmer's fault at all, and now there's this new software update, but you have to hope that there is some real lessons to the aviation industry here where they won't be pressuring FAA regulators, and maybe some lessons for our government as well, and for the FAA to stand up to that, to have more of a backbone, to not be pressured in the same way. Like that's what we rely on regulators for.
Yeah, it's crazy. Airplanes have millions of lines of code, of course, in their systems, and even just a mistake in a few lines can be deadly. But again, we don't want to go and just say that's just the software problem. There were many problems made by Boeing in this case.
Our intention here is not to make folks afraid to fly. I think that there are some real lessons learned, and my hope is that folks still feel safe when they're getting on a plane.
I'm a numbers person, and even though I've flown almost 100 times, I have a fear of flying. But I know that when you're going to New York, which you go regularly, the safest way you can go is flying. Because I'm a numbers person, I know probability-wise, every time you get on a flight, you have a much, much more likely chance of getting safely to your destination than you do for any other kind of transportation, for any kind of long-term travel. So absolutely, Boeing took a real reputation hit as a result of this. But the reality is that the vast majority of Boeing planes have been safe for many, many decades.
Absolutely. So now we're going to switch gears to another software disaster.
Yeah, Y2K. Y2K, for those of us who are over 30 years old, we can remember. And for our listeners who are under 30 years old, you may have heard about it, but you maybe didn't live through it. It was an error with dates when the year 2000 hit in all kinds of different software systems. And here's how it went. Basically, when we went from the year 1999 to the year 2000, many software systems thought we were going from the year 1999 to the year 1900.
Oops.
And you might wonder why that was. It's very simple for most of them. Now, there were many different variations, but the most common issue was that they were using only 2 digits to store the year. And so a lot of early software systems that were built in the 50s, 60s, 70s, even the 80s, we're trying to save a little bit of memory by using 2 digits instead of 4 digits to store the year. Now, if we think about that in terms of bytes, you can store 2 digits in just 1 byte. And for 4 digits, you're generally going to need 2 bytes. So basically, every time a date was stored, the programmers were trying to save 1 byte. And you might say, wow, 1 byte, why would they try to save 1 byte? That sounds really silly. Well, memory was really expensive in the 60s and the 70s, and that 1 byte would really matter. And you see dates actually all over the place in computer code. I'll give you an example. Let's say you have some document and you want to keep track of all the different changes. Then every time there was a change, you might keep track of a date. Now, even if it's only one extra byte every time you keep track of that date, for that document alone, we might be talking about tens of bytes, maybe even hundreds of bytes. And when hardware costs are as much as $10 per kilobyte or even $100 or $1,000 per kilobyte, if we go back to the 60s and 70s, then those single bytes start to really, really matter. And so they add up, and people were trying to save money by just using as few bytes as possible for every single date. Of course, then you have a real problem when you start to actually get to the point that nobody was thinking their software would ever get to, where it's still being used 10, 20, 30 years after it was written, and we actually get to a date that it can't support. And so that is the crux of the Y2K problem. Old software that was storing dates that only could handle 2 digits, hitting the year 2000, and then thinking it's the year 1900. And you can imagine how, let's say there's a device that says, well, what date is this happening on? And you enter a date, and then it thinks that date is before the last thing that happened in the software, and suddenly it's like, uh-oh, this is an illegal date, and it just crashes or something like that.
So what I remember from Y2K, and I obviously didn't understand the software back then, was just feeling like, oh my gosh, everything might stop working. Like the whole world, I remember imagining all the lights could go out or something like that.
There was a huge amount of hysteria. There were books published, general public books, like books written to lay people that were about all the terrible things that were going to happen in the year 2000. There were movies made. The government got involved. There was a Y2K task force in the US federal government and in most other countries' governments. There were people who their whole job was mitigating Y2K. They were like Y2K consultants. You'd hire them for your company. They'd come in and try to figure out how to fix these problems.
So did those consultants start existing in 1999, or were we aware of this all? I mean, I remember it like being a thing in 1999, but I imagine software developers knew this was going to be an issue for a while.
Right. I mean, the people who wrote that code, who were trying to save that byte, and they weren't necessarily making the wrong decision all the time, right? Sometimes that byte, like they really needed to save it because that's just how expensive things were back in the 60s and 70s. But they knew, obviously they knew back then that if this software is still running in the year 2000, it's going to think it's the year 1900. They knew that. And so what they would rationalize is there's no way this software is still going to be used in the year 2000. And of course, the way software is not only do some old systems keep getting used, but systems get built on top of systems. And some systems that are software systems are embedded systems. So they're working in some hardware device and no one's ever going in there and changing that software. So you think about something like a medical device, unfortunately, right? It often will have the original software that comes with it and never get updated, especially back when these medical devices were being built in the 70s and 80s. So yeah, people knew, and people already started talking about this being a major problem starting in the 80s, and certainly by the mid-1990s, it was already like a thing. Like trying to make sure that your software was ready for the year 2000 was a thing by the mid-1990s. So then the hysteria really, though, built up in the late 90s, starting like the year 1997, 1998, there really started to be this mass hysteria about what is going to happen in the year 2000.
And while Y2K wound up not, all the lights stayed on, right? The world did not end, but there were some real consequences to this software bug.
So I'd say the big consequence, the biggest, was the amount of resources, time that were put into actually mitigating for it. So some estimates say it was as much as $300 billion, and that's in 1990s money that was spent on mitigating for the disaster, so getting ready for Y2K. That in and of itself, I mean, just think about what $300 billion could do. We could probably save tens of thousands of lives with $300 billion. So economically, it was a disaster, just what this led to in terms of the cost to fixing it. Number two, there were some real errors that happened. There were credit card processing systems that stopped working. There were transportation systems that had some errors. There were real things that happened in the year 2000. They were relatively minor compared to the hysteria. The worst ones I've seen were medical testing results that were wrong about some life and death decisions. That may have very well led to some real people either losing their lives or not getting a certain treatment that they needed, etc. So there were some real medical test results that were wrong because of the Y2K problem. However, the amount of hysteria and what people thought was going to go wrong. Like, I remember my dad, because he was into this kind of accident research stuff, talking to some people who thought, well, these countries that are not going to update their systems, maybe their missiles will launch or something in the year 2000. Of course, nothing like that happened. So the level of hysteria versus the problems that actually happened was probably out of line. However, yes, there were real errors that happened. They were not as bad as most people were predicting.
So what lessons can we take from this in terms of software?
I think
put 4 digits on your dates?
Well, I think there's more than that. I think it's that software ends up getting used a lot longer than we think it will. And so making good technical decisions is important from the beginning, because it's very possible that systems will build up over years and become dependent on the software that we're writing now. So we actually, all as software developers, have a lot of responsibility to the public to do a good job. Like, our jobs are important. Everything depends on software. Everything runs on software. Everything from medical tests to missiles to airplanes to even our lights in our house. And all these things are important, and there's nothing that software doesn't touch today. And so we have to always be vigilant as software developers to be making forward-thinking decisions. However, I have bad news, which is that the problem continues. Y2K was 21 years ago from when we're recording this, but there is another problem. It's called the 2038 problem. We're going to go through something like Y2K, possibly again. It won't be as bad because everyone's much more aware of it now.
Why 2038?
So here's the thing. In Unix, which we did a previous episode on, what is Unix? The original way of storing dates was you store the number of seconds since Unix was created. And Unix was created in 1969. Now, those dates were traditionally stored in 32-bit integers, 32-bit signed integers. And a 32-bit signed integer can go up to the number approximately 2 billion, a little bit more than that. And it turns out there's going to be 2 billion seconds between 1969, when Unix was created, and 2038. And so these Unix systems will also roll around back to an earlier date, just like what happened with these Y2K problem systems. And this will just happen in the year 2038.
So should we just throw out all of our Unix systems?
Well, the problem is that Unix defined the standard, but almost every other Unix-like system, including Linux, uses a standard. And Linux is in just about everything today, right? When we talked about that in our previous episode, what is Linux?
So I'm imagining all the devices in our houses exploding.
Well, they're probably not going to explode, but they very well might have errors or not function if they didn't get updated. And there is an easy update for this, relatively easy, which is modern systems switched from using a 32-bit integer to using a 64-bit integer for counting the seconds.
Didn't we just kick the can down the road?
Well, yeah, we have to update the system, just like the Y2K systems had to be fixed. Any of these old systems that are still using 32-bit integers need to be fixed before the year 2038.
Okay, but what about when we switch the 64?
Oh, 64-bit. Well, that number is so big. It's such an unimaginably big number. Unless we're still going to be around after the sun burns to a crisp, we're not going to have a problem.
Are you
Yeah, I'm sure.
Okay.
That's not kicking the can down the road. We just need to replace the 32-bit dates with 64-bit dates, and we'll be totally fine. But yeah, it's a real issue. And so, people in even Unix, as forward thinking as it was when we talked about it in that prior episode, they weren't thinking, well, people are still going to be using this in the year 2038. And it turns out that some systems built in the 70s are still going to be used in the year 2038.
Yeah, I guess it's hard to think about that when you're working on something late at night in the 60s or 70s, like someone might still be doing this.
Nobody imagined 68 years later the software would still be used. But, to be fair, they were working in the early days of the software industry.
Yeah.
And we had no idea that a lot of software systems would have the kind of longevity that they had, because they were pioneers. They were working at a time that everything they were doing was new. So we have to forgive, I think, the people who created the Y2K problem and the 2038 problem. But at the same time, it's crazy just how much money was spent mitigating Y2K. It's terrible about the real people that had problems as a result of Y2K. As a whole, though, there's 2 lessons here. I think, yes, there's a lesson we talked about earlier, also related to 737 MAX, that a lot of these errors are really human errors. Somebody was making a business decision. They wanted to save a little bit of money on memory, and that led to problems for a lot of other people. However, there's also a lesson here, I think, about the longevity of software systems. And that as programmers, we need to be aware, you know what, we're building something not just for today, we're building something that might be for all time.
And there has to be an accessible way to update things.
Absolutely. And I think that's going to be the biggest issue with 2038, is that there are going to be some early Unix systems, and including some early Linux systems, that have these 2038 problems, and they're going to be embedded in hardware devices that are going to be hard to update or that nobody even thinks to update before 2038. All right, well, we hope we didn't scare people too much this week talking about software errors and major disasters. We might do another episode on some other software disasters if people find this interesting. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
And we look forward to seeing you next week.
Thanks for listening.